So we're going to solve a truss problem as an example so you'll have something to refer to if you get stuck on any of the homework. So we're going to find all the forces acting in this system. So here we have a truss. It's pinned here and it's free on this end. That means it could rotate around this point. So we could lift the bridge up if it were a drawbridge, and this end could come up and it would rotate around A over here. So what are the reaction forces? These are the forces that are exerted by the ground on the bridge. We have a load of 750 pounds here at C. So there's going to be a reaction force at E and a reaction force at A that are pushing up. It's the ground pushing up because those have to counterbalance the load C to keep the truss in static equilibrium. So how do we calculate FE and FA? Well, step one. Sum of the moments is 0. If you recall, moments are forces that are trying to make this thing rotate. And again, if it could rotate, it would rotate here around A. So this end at E could come up. It's not pinned, it's just resting there. So the amount of force applied to rotate something, the moment, is dependent upon the magnitude of the force and the distance it is from the point of rotation. So in our case here, we have that sum of the moments is 0. Well, FA is at the point of rotation, so whatever the force is there, it's not trying to rotate it because it's 0. The distance is 0 from the point of rotation. And then we have 40 feet away, we have FC. And 80 feet away, we have FE. So it's 0 plus 40 times negative 750 plus 80 FE. We divide both sides by 80. We get 375 pounds for FE. Now, step 2. Is that the sum of the external forces is 0. We know that because the bridge isn't moving. If the sum of the external forces weren't 0, it would be moving up or moving down or sliding one way or the other. And it's not. So if we add all those forces together, we get 0. And in this case, all the external forces are acting straight up and down, like straight up or straight down. So we don't have to do any trigonometry for it. We just get 0 equals FA plus FC plus FE negative 750 again, negative because it's in the downward direction. That's all the negative means. So FA is 375 pounds. And that should make sense. We have a symmetric truss with the load right in the middle of the truss. So we should have symmetry here. So now we will use the free body diagrams to calculate the forces at each joint. And as we do this, we're going to take advantage of the symmetry in the system. When we find AB, DE is going to be, because of symmetry, DE is going to have the same, it'll be in the same, they'll both be in tension or both be in compression, it'll be the same amount of force. So that'll make it easier to solve this truss. So let's start with point A. And we know at A we have FA, and it's acting in that direction. We have FAB, we don't know what direction that is yet, but we're going to figure it out really quickly. And FAC. There's the point C. And we know that this is 375 pounds. Well, now, the sum of the y components has to be 0 because we're in static equilibrium and this point isn't moving, so the sum of all the forces acting on the point has to be 0. Well, there's only going to be 2 y components here. FAB and FAB in the y direction, which means this has to be acting down to counteract FA. Which means that has to be that way. So FAB is going to be acting in that direction. And we know, because those have to be counteracting, that FABY is going to be 375 pounds. And negative just indicates the direction it's going down, because FA is going up and they're opposite signs. Now, we know this is 36.9 degrees, which means this is going to be 90 minus 36.9. So we get 53.1 degrees. For that angle. That's going to be important because we need to find FABX. All right. Well, the tangent of 53.1 degrees is going to be FABX over FABY because it's opposite over adjacent. So FABX is going to be FABY times the tangent of 53.1 degrees, which will be that, so we get 375 degrees times the tangent 53.1. So we get 499 pounds. Now, some of the x components has to be 0 also. And since FABX and FAC are the only x components, FAC is also going to be 499 pounds, but in the opposite direction. So we have now solved FAB or FAC. We have FABX and FABY, and we can use the Pythagorean theorem to get FAB, which will be 624 pounds. So we could take, that's 375 squared plus 499 squared, take the square root. So if we come over here, I'm going to bring this diagram over. Now if we come back here and look, we have 624 for FAB, and FAB is going that way, which means FAB was in compression and it's pushing out against that compression. That means that we also have that's just not neat enough. 624 pounds over here. And if you'll notice, we have 499 pounds for FAC, and it's pushing this way, which means it's pulling its ends in. So it's under tension, and it's pulling in, reacting against that tension. Which means we have 499 pounds there also. So we can now move to B for a free body diagram. At B we have we know the direction for FAB. We also have FBD and FBC. And we know that this one is 624 pounds. we actually know more than that. If we come back over here and look, we know that we have 375 and 499 for the x and y components. And that's going to be important because let's make this a little bit, break it down here. The sum of the y components is 0 because it's not moving. So we know that net, it's not moving up and down. There's net 0 force up and down, which means FBCX is going to have to be counteracting that, which means FBC has that direction because that has to be 375 and that has to be 499 pounds. Because the angles are the same, we're going to get the same triangles. Which means that's also going to be £624. Now, the sum of the, because the sum of the x components is 0. Again, it's in static equilibrium. So if we add up all the x components acting on it, we get a sum of 0. Well, that means FABX plus FBCX plus FBD is 0. So that force and this force together have to be 0. Those three are the three forces acting in the x direction. But we know that this is 499 plus 499 plus FBD equals 0, which means FBD is going to be negative 998. Again, that negative just means it's going in this direction. It's counteracting the forces here and here that are both going that way. To counteract those, it's got to go the other direction. So now we know 998 pounds going this way, and we know that $624 there, meaning that BD is in compression and it's pushing out against it, and BC is in tension and it's pulling in against that tension. And because of the symmetry, that will also be 624. Now we've solved the entire truss system. And again, the symmetry very often, not always, but symmetry very often makes trusses significantly easier to solve. So here's our whole system, and now we can just write out the sum of the forces on here. So FAB is 624 pounds, and it's in compression. It's pushing out against the compression. FAC is 499 pounds, and it's pulling in against the tension that it's under. FBC is 624 pounds, and it's in tension. FBD, 998 pounds, and it's in compression, and it's pushing out against the compression. FCD is 624 pounds, and it's in tension, just like FBC. FCE is 499 pounds, and it's in tension. And FDE is 624 pounds, and it's in compression. So that's what each one of the members in this truss system, that's the state it's in, whether it's compression or tension and how much.